Hono is a web application framework that allows us to build APIs. And in a recent video here on the channel, I did a deep dive into how to set this up to get a nice, fully documented API. And in this video, I'm going to show you how to deploy it. So one of the great things about Hono is they actually support a lot of different runtimes and platforms. And in this video, I'm going to show you how to deploy to a few different platforms that are Node.js based or have a Node.js compatibility layer. So I'll show you how to deploy to render.com, fly.io, Vercel, both the Edge runtime and the Node.js runtime, and of course, Cloudflare workers. Now in this video, I am going to be using the Hono OpenAPI starter repo that I created as a base to deploy to all of these platforms. But if you have your own Hono applications that you'd like to deploy to these places, you'll be able to follow along as well. Now, all of these examples are available over on GitHub. I have this repo, Hono node deployment examples. And so for any one of the deployments that you'd like to deploy to, head into that folder. You can see all of the files that I configured. And specifically, if you want to use the Cloudflare template, I actually just have that as another branch on the main starter repo. So if you look on here, check the branches, there is a branch called Cloudflare. So if you just want to start from that Cloudflare base template, you can actually just clone that specific branch. So let's dive in. My name is CJ. Welcome to Syntax. Now, first up, we need to make sure that we can actually run our Hono application directly with Node.js. So far, we've only been using this in development, and you can see we're using this tsx command. So tsx stands for typescript execute, and essentially what it does is it transpiles your code just in time and then runs it through Node.js. But when we're running in production, we want to run the fully built code. We don't want to use something like tsx. So what we can first do is build our code and see what happens. And so right now you can see we have a build command of tsc. So this uses the TypeScript compiler, and it looks at our tsconfig, uses all of these settings, and then it's going to output the code into dist. So the code that gets generated and built here is the code that we're going to want to run with Node.js. So let's see what happens if we build it. First of all, you can see we have a dist directory, and you can see that Git is tracking it. We want to make sure we don't commit this built code because any system we deploy it to is going to run the build itself. So if we head over to our git ignore, make sure that we throw dist inside of there, and that way Git is not tracking the changes for that dist directory. But aside from that, if we look in here, we have actual JavaScript files, right? So you can see there's our entry point, there's our app.js, and so we should be able to run this with Node.js. So let's give it a try. If we do node and then dist source index.js, we hit our first issue. So you can see it says cannot find module app imported from index.js. So if we look in the source code, we look in the built code, we look at index.js, we can see that it's trying to import app here. But this import actually needs an import extension. It needs a .js on there because that is the ECMAScript module standard. And so since we're running the latest version of Node.js, we have our type set to module. It expects to see file extensions. So what we need to do is whenever we build our project with TypeScript, we need to make sure that those extensions get added. And for this, we can use a project called tsc-alias. Now, one of the main purposes of tsc-alias is to actually replace all of our import aliases. So that's actually another issue. So right now we don't have file extensions, but if we look at one of our other built files, like in source, and let's just say app.js, you can see that we have these import aliases here. This type of import alias is only supported by TypeScript. So this also needs to be converted into like a relative file path. So that's one thing that tsc-alias can do. But on top of that, it can also add the extensions to all of the imports for us. So what we're going to do is install tsc-alias as a dev dependency. So if I do npm i-d tsc-alias, we'll grab that. And then in our package.json, we need to update our build script. So right here, we'll run TypeScript. And then immediately after that, we'll run tsc-alias. And this will essentially go through all of the built and bundled code and convert all of those import aliases. And we can add a setting to add file extensions. So let's do that. Now, if you head to your tsconfig.json, you can actually add a section here specifically for tsc-alias. So we're going to add tsc-alias here, and then we can specify all of our options. If you look in their docs, they have a lot of options, but the one that we care about is resolve full paths. And we're going to set this to true. And this is what's going to add those import extensions. So we'll set that to true. And now let's run a build. Now, before we run it, let's go ahead and add a script to our package.json. So most platforms that support Node.js expect there to be a start script, and that start script says how to run the app, and we can basically just use node. So we can say node go to the dist directory, into the source directory, grab that index.js. And so now any platform that expects that to exist will be able to run it. And a lot of platforms will actually run our build for us. So they're going to run build, and then whenever they need to start it, they can point at that built code. And so now if we do npm start, it'll see that command and our app actually starts up. And so now we have built our code in a way that is compatible with the latest version of Node.js. And if we take a look in that dist directory, we can see that any imports added the import extension there, and then anything that had a import alias now uses that relative file path. So our code is built, and it's now in a format that the latest version of Node.js can actually run. Now, if you decide to use the template that I have on GitHub, I went ahead and added those build settings, so you won't have to add that manually. They're in the repo already. They're ready to go. You've got this build script, and you've also got the start script. So if you start from the template directly, you should be ready to start deploying. Now, before we deploy, we need to make sure that we have a database in the cloud that our deployments can connect to. And we are using SQLite as our database, but there are various platforms out there that allow you to use SQLite in production in a scaled way. And so Turso is one of those projects. So essentially what we can do is add our database here, and it's actually going to give us a remote URL that we can connect to. And that libsql database client that we set up in the last tutorial is ready to go to actually connect to that remote SQLite instance. So here in Turso, I'm going to create a group. I'm just going to call this my tasks group. I'll put it in Denver because that's where I am. And then we'll create the group. Now from here, I can create a database. So I'll do just that. I'll give it a name. We're going to call this the tasks DB, and we'll create. Now I can create a secret and connection URL. So if I click here and then click create token, you can choose if you want it to expire. In this case, I don't, because it's going to be for our long-lived deployments. And then you can give its access. In this case, we want read-write access because it needs to be able to read and write to the database. And then click create token. Now this token should be kept secret. This is essentially like a password to write to your database. If anybody has this token, they can literally connect it directly to your database, create tables, delete things. You want to protect this secret. But essentially what we're going to do is use this URL and token to push our schema to the remote database and make sure that when we're running our app locally, we can actually connect to that remote instance. Because if we can, then we know that whenever we create our deployments, they'll be able to connect to the instance as well. So locally, I'm going to update my env to use these as the database URL and database auth token. So I'll grab this URL, and then instead of a local file, now we're pointing at something in the cloud. And then if you look at our env file, we also are expecting another variable called database auth token. And this is how we will authenticate to that database. So here I can grab this token, throw it in there, make sure to delete it after I publish this video. And now we should be able to connect to that remote instance. And so if we just start up our app locally, I'll just do npm run dev. Let's try connecting to it and see what happens. So if I, for instance, try to hit that tasks endpoint, boom, we get a SQL error that says no table exists task. So first of all, this is good. This actually lets us know that we're connecting to that remote instance, but that remote instance needs the schema, so we need to push it. Since my env has the connection information for that remote database, when I run drizzle-kit push, it's going to push the schema to that remote database. So if I do pnpm drizzle-kit push, that is going to attempt to push our schema. Now, one thing I forgot to set up is in our connection settings, we do need to tell it that it's using the turso driver. Now, I will mention there's a newer version of Drizzle that uses a slightly different config. For this project, we are still on Drizzle version 0.33. And so for version 0.33, you can also add a driver setting here that is set to turso. Now, if you look at the latest Drizzle docs, they actually have a dialect called turso that you would use instead. But since we're on version 0.33, these are the settings that we need. And I will be creating a video pretty soon that talks about the latest changes in Drizzle, but they're pretty great. But right now we're just going to stay on the older version. So set the driver to turso, and now let's try to push our schema. There we go. So that actually pushed the schema to the cloud, to the SQLite database running there on Turso. And so now if we start it up and then try to visit the tasks endpoint, we get back an empty array. Sweet. And let's actually head to our API docs and create a new task. So let's just call this learn Hono deployment. And it is currently not done. So if I send that, that puts it in the database, and this is in the cloud. And so this is one way we'll test our connection to the database once we deploy. We'll make sure that we can see this one task, because that means we're connecting to that remote Turso instance. And so at this point, we have a Turso DB. We're ready to go. Anywhere we deploy to, we can use that auth URL and auth token and connect to that remote database instance. Now, the first place we'll try to deploy this is render.com. So from the dashboard, I'm going to choose deploy a web service. Here, I'm just going to choose public Git repository. If you already have your own Hono app, you can connect Git and then point it to a repo. In this case, I'm just going to deploy the starter template. So I'm going to throw the link in here and then connect it up. Now we can give it a name, create a project if you'd like to, and then choose all of our settings. So we are using node.js. We're on the main branch. You can choose your region based on where you are in the world. And then all of the other settings we can leave exactly the same. So because we set up our start script, our build script, everything is ready to go for render. So you can see here the build command is going to install dependencies and then run the build. So that's going to generate that dist directory. And then to actually start the app, it's going to do pnpm run start, which runs that start script that we created. So we shouldn't have to change anything here. We'll just choose the free tier, and then we can add all of our environment variables. Now, one nicety is you can click add from env, and then if you head to your project, you can grab your settings and then just copy them directly in. But we do want our node env to be production. Render is set up to use the port environment variable, so we can set this to whatever we want. And if we leave it blank, they're going to generate a port for us. We're going to set the log level to info. And then lastly, we'll update our database URL and auth token. And of course, these are coming from turso. So let's add those variables and deploy. Now we actually got a build error. Now I'm seeing that it says dev dependencies are skipped because node env is set to production, even though it's running the build. So let's go ahead and just update that to make sure that we get our dev dependencies, because without the dev dependencies, we don't have the type package. So in our environment, let's actually just set node env to development for now. Deploy, and then after the deployment, set it to production. I'm curious if they have specifically build environment variables, because our build environment variables need to be different than when we're actually running. But let's see if this helps. Yeah, so it looks like it's able to build with that node env. I'll have to research to see how we can get the build working without that, or maybe have different environment variables for build. But for now, we should be good. And sweet. So it looks like it started up. Let's try visiting it. We can hit the home page. Awesome. And if we go to the /tasks endpoint, we get back a task. And so it's connecting to that remote turso instance. Sweet. So we deployed on render.com. Next up, I'm going to show you how to deploy on fly.io. Now, fly.io is going to create some various files in our directory. So I'm actually going to clone this repo down and put it into a new directory, so that way it's not going to be on the main branch. And I'll have a separate repo that has a folder for each of these different deployments that has all of the files that got created specifically for those deployments. So here I'm just going to clone this into fly.io example. And then if I head in there, let's just install dependencies and then copy our env.example file to our .env. I just want to make sure we can run this thing locally before we deploy it. And so from there, if I do npm run dev, looks good. I can hit it locally. I can do that. Yeah, there's no local table. This should be fine. This should be fine because we're going to be connecting to the remote instance anyways. Okay, so first off, you will need to install the flyctl CLI tool. So if you head to this page, install it for your operating system. From there, from the command line, you'll either sign up or you can sign up on the web. And then from the command line, do fly auth login. Once you're logged in, you are ready to deploy. So from this directory, I'm going to run fly launch. It'll detect what kind of app it is, and then we can change our settings. And so in this case, I just want to change the name. So I'm going to say yes here. That'll launch the browser, and then we can update any of the settings that we'd like. And so in this case, I'm just going to call this the Hono Open API Starter Fly IO. So I'll call it that. From here, you can customize everything else, and you can add the Sentry integration. So I'm going to go ahead and do that, and then click Confirm Settings. Sweet. And with those settings, it's going to start to launch. And this is a perfect time to talk about Sentry. So if you head to sentry.io/syntax, you can get a code for trying Sentry for free using code tastytreat. And so Sentry is an error monitoring platform. Essentially, you add it to your app running in production, and then any errors that happen, it logs them in the dashboard, and you can get some insight into the types of errors that your users are running into. And so since we're deploying, we absolutely should have Sentry enabled for our deployments. So if you want to try it for free, head over to sentry.io/syntax. Awesome. And so what this has done is it has actually created a Docker container for us. It's building it. It set up all of the settings. And if we look in our source codes, we can see that it added that Docker file. It added some configurations files. Looks like it also added some dependencies for us. But specifically, when you're deploying to Fly, you're going to get all of these files created within your repo. So at this point, it says it's deployed, but we do need to go set up environment variables. So if we head to the Fly dashboard, refresh, we should see our app now. And then we can go specify our environment variables. So if we head to secrets, then we can add each of the secrets that we need. And so we're going to need to add all of them. I'm going to add my node env, set that to production. I'll add my log level, set that to info. I'll add port, and they set that to 3000. And then I'll add my database URL. And lastly, we'll add our database auth token. We'll set that. And now here in your secrets, if you see a yellow dot, then that means these aren't going to take effect until you actually deploy. So from here, we can now just say fly deploy. It'll pick up all of those latest environment variables, and we should have a deployed app. Sweet. So we should be able to give it a try. If we head here, the index page loads. That's awesome. And can we head to /tasks? We can. Sweet. So we deployed to fly.io. Next up, we're going to deploy our app to Vercel. Now, Vercel has two different runtimes. It has the nodejs runtime, and it has the Edge runtime, which is a lightweight JavaScript runtime based on web standards. Now, it's possible to run on both of these, but they both will require something slightly different. So first, we'll deploy to the Edge runtime. Now, I'll start with the Hono API starter base template. Let's just grab this URL, and then I'm going to clone this into the Vercel Edge example. We'll head in there, and then I'll set this up. Install dependencies, create my .env file, push my database schema, just make sure that I can run it locally because we're going to want to test that before we deploy it. Okay, so I tested locally, everything looks good. Now let's set up the deployment. So if you look in the Hono docs, they have a section for Vercel. This document specifically talks about deploying it with Next.js, but we can still use it as an example. And so you can see right here that this exports get and post. And so essentially we need to create an entry point that does this same thing. It exports all of the HTTP methods that we support, and it's going to use handle from Hono/Vercel. Now we don't have to install anything separate for this. This is just built into the base Hono dependency. So we should be good to go there. And if you click this link, you can see all of the supported methods. And so essentially what I want to do is I want to make sure that my API supports all of the supported methods. So we're going to create an entry point that exports all of these specific methods. Now the way that Vercel works is it expects your serverless functions to live in a folder called API. So I'm going to create a folder at the root here and call it API. Now inside of there, I'll create my function. That's just going to go in an index.ts. Now, if you watched the original tutorial, you saw that I talked about how app.ts is just a regular plain old Hono app. But if you look at index.ts, that imports the app and then runs it with this node server package. And so we kind of need to do a similar thing, but for Vercel. And so over here in our API index.ts file is where we're actually going to write that handle code. So we will pull in handle from Hono Vercel. We'll make sure to export const runtime as Edge. And so this makes sure that we're deploying to the Edge runtime, not the nodejs runtime. And then from here, we need to import our app and then export all of our handle functions. Now, the code that we have written with TypeScript is not directly supported on the Edge runtime. So if we were to try to import this app directly, it can't resolve these import aliases. There's some other various issues. So basically what we need to do is whenever we are running our app on Vercel, this file needs to actually import our built code. So let's run the build command. That'll generate the dist folder, and then we're actually going to import that app from the dist folder. So now that we've run the build, we should have a dist, and then there we have source, and then the app.js. This is the file that we want to import into our serverless function here. So I'm going to say import app from, we'll go up a directory, into the dist directory, into the source directory, and then grab that app.js file. Now I have some linter errors because typically you shouldn't import things from the dist folder, but when our code is running on Vercel, it will have built our code so that dist folder will exist. So I'm going to go ahead and ignore no import from dist. The other thing is this is bundled JavaScript code that doesn't have any type declarations. So TypeScript complains and it's like, hey, I don't have the declaration file here. And so I'm actually just going to do a tsc-expect error. So that way it doesn't complain about the missing declarations. And then I have to ESLint ignore using tsc-expect error. And they have to be in this order. But ultimately, I'm just trying to make sure that my linter is happy and also that the TypeScript compiler is happy. But now that I have our built app, we can pass it into handle. And so you can see in their docs, they are exporting get and post like this. And so I want to do the same thing, but I want to make sure I include all of the methods because our API also has endpoints for delete requests and patch requests. We might even get options requests if we ever enable cores. So I need to make sure that I support all of these as well. So I'm just going to export all of these. And I'm going to use some command line foo to say this, and then this, and then this, and then this. Like that. And I'll make sure I update this one too. Okay, so at this point, we have an entry point that will run our Hono application and handle all of the possible incoming requests. And essentially what we're doing is we're taking all of our code and turning it into a single serverless function. So whenever a request comes into our app running on Vercel, it's going to hit this file first, which in turn loads our entire Hono app. and then it can respond to any of the incoming requests. But essentially what we want to do is we want to reroute all incoming requests to that specific serverless function living there. So for this, we can add a vercel.json file. So I'm going to add a vercel.json. And inside of here, we need to have a rewrites section. And the source of the rewrites is coming from anywhere. So this is a regular expression that says /anything. And then we want to send that to our API function. So any request that comes into our application, we are then going to send it to the destination of /API. So if someone requests /tasks, it's going to hit this regular expression. That'll then redirect it to /API. That will then go into this folder, see this, and then run it against our Hono app here. Now, one more thing we should do is add a folder called public. So we're doing a thing that they didn't really expect us to do on Vercel in terms of only deploying a serverless function, not having any static files or anything like that. And so what we need to do is create a public folder and then just make sure that this folder exists whenever we deploy. So I'm going to add a file in here called git keep. This is just a convention to make sure that this folder lives in our Git repo, but it's also going to stick around for whenever we deploy our application. But now we are ready to try deploying. So I'm going to use the Vercel CLI. You potentially could push this to a repo and then hook it up. I haven't tried that yet, but I am going to show you how to do this from the CLI. So here, I'm just going to run Vercel and set this up. So yes, I want to set up and deploy this. We'll deploy it there. This is not an existing project. I'm going to call this the Hono starter Vercel edge. The code lives in this directory, and then you'll see that it's detecting these settings. And so essentially what will happen is when we run our deploy, it's going to run npm run build, and we already set up that build command earlier. It'll do a pnpm install, and in this case, it'll just have that blank public directory. But because it built it, that serverless function can actually require in that app that lives in the dist folder, and we should be good to go. So I'm not going to modify these settings. This should be everything that we need. After this, all we should have to do is add our environment variables. Awesome. So if we head to the Vercel dashboard, we should have a project, and now we can go in and add our environment variables. So if I head to settings and then environment variables, scroll down, and this is where we need to add them here. And what's nice is if you have them on your clipboard from a .env file, you can just paste it in, it'll detect all of them, and then we'll click save here. And then now that I have these environment variables, we want to run a redeploy. So I'm going to go over to my deployments and then just say redeploy. And if we did everything right, we should be good to go. So if we visit our app, it loads up, sweet. And if we head to /tasks, it's able to hit the API. Awesome. Now, when you're using Vercel, you typically want to be able to test this locally too, because sometimes you might do some Vercel specific things like caching and stuff like that. So in order to test things in a Vercel-like way without having to deploy it every time, we can run Vercel locally. So in this directory, I'm going to install Vercel as a dev dependency, and now we can add a specific task. And so in my package.json, I'm going to add another script, and I'm going to call this Vercel dev. And so here I can say Vercel dev. And essentially what this will do is when it runs locally, it'll behave exactly like it would running on Vercel. So it's going to see that Vercel.json, it'll see that API directory, and everything will run in a similar way. And so now that I have that, I'll need to make sure that my dist directory exists. So one thing you might do is you could combine this and say, well, run the build and then do Vercel dev just to make sure that dist directory exists. But let's try it out. So if I do npm run Vercel dev, that'll build it and then spin up the Vercel CLI. Now, maybe someone in the comments can help me out. I don't know why, but for whatever reason, this requires me to use yarn. Maybe there's another setting I can specify, but if you get an error that says yarn command not found, you'll need to install yarn globally, and then you'll be able to start it up. But from here, we should be able to visit our app and visit all of the endpoints. But in this case, it's running in a way as if it would if it were running on Vercel. So this is a good way to test things out without needing to fully deploy to Vercel. Next up, I'll show you how to deploy to Vercel, but using the node.js runtime. And so this is different from the Edge runtime because it's not as lightweight. And you'll typically need this if you're doing anything that's really node specific and maybe aren't using web standards. But Hono has a built-in adapter for node.js. So we'll be able to use that, and we'll set up our app in a similar way that we did for the Edge functions. So for this example, all of the setup steps are exactly the same as for the Edge runtime. The only difference is going to be our entry point for running the application. So if you want to deploy to the Node.js runtime, go back in the tutorial, follow what I did there. Essentially what I'm going to do is I'm just going to copy the folder that we created and show you what needs to change if we want to run on the Node.js runtime versus the Edge runtime. Okay, so I copied that folder over. Everything will be the same. You'll still need your vercel.json. You'll still have like your dev script. You'll still need that empty public folder. But the one thing that we'll need to update is this index.ts. And so instead of importing handle from Hono Vercel, we'll need to import handle from the Node.js adapter that comes from Hono. And so if you look in the Hono docs, if you go to Vercel and then go all the way to the bottom, you can see that they have an example here. And so one of the first things is we're not exporting that variable that says we're in the Edge runtime. So over here, we'll need to make sure that we remove this. So without that, we are now running in the Node.js runtime. Next, you'll see that we're pulling in handle from node server instead of Hono/Vercel. Now, because when I set this up locally, we are using node server as well. If you look at our index.ts, which is what runs when we do npm run dev, it's pulling in serve from Hono node server. But over here, we need to pull in handle. So I already have Hono node server as a dependency. If you're not using this starter template, make sure that you install Hono node server, and then you can grab this handle function. Now we'll import that handle from here instead. And then we just need a single export. So instead of exporting all of these methods, we're just going to export a single call to handle and pass in the app. The other thing is we need to disable Node.js helpers. So in our .env, we're going to set Node.js helpers to 0, and then we can try running this locally. So in the last example, when we set this up, we have a Vercel dev command that's going to build the code and then run Vercel dev. And so now locally, we can test it in the Node.js runtime. So I'll do an npm run of Vercel dev. It'll build it and then start it up, and should be able to visit it. Looks good. I can visit the reference page. Awesome. So it runs locally. Now let's try to deploy this. Now, because I copied this folder, I do need to remove that Vercel folder that got generated. If you're starting from scratch, you don't need to do this, but I'm going to deploy this one separately from the one that's the Edge runtime. So I need to make sure that that Vercel folder doesn't exist. But now I can run Vercel and create a new project. I can give it a name, and then everything else will be exactly the same. We'll just keep all of these settings, and we're deployed. I'm going to have to go set up those environment variables just like we did for the other project. So we'll head here, go into settings, environment variables, but we'll need to make sure that we also set Node.js helpers to 0 whenever we're adding these environment variables here. So I'll just do that and then paste in the rest of my variables, save, redeploy, and we should be good to go. And now we'll go redeploy. So if I head to deployments, we will say redeploy. Okay, so it redeployed. We can at least see our home page. That looks good. We can see our reference page. Awesome. But what happens if we hit an endpoint? Let's try it. Oh no, server returned HTTP status of 401. So our environment variables are set. So this is something I would expect if maybe we have the wrong auth token set for turso. But if we go to our project and we go into settings and then environment variables, our database auth token is set. So I debugged this for days. And ultimately it comes down to when you're running your code in the Vercel Node.js runtime, it doesn't work as well with included libraries that attempt to use the built-in fetch. And so there's this issue from a few years ago that asks how it works, but these people mentioned just using node fetch. And so that's what we're going to do. So here we're going to install node fetch. And so this is a version of fetch that was essentially like a polyfill that existed before fetch officially got added to Node.js. So fetch does exist inside of Node.js, but for whatever reason, when it's running here on the Vercel Node.js runtime, there are some issues that pop up. So now that we have that node fetch dependency, essentially what we need to do is change the fetch that's used by our database adapter. So if we look in source, DB, and then index, you can see here that we're using the libsql client, and they actually allow you to pass in a custom fetch. And this is what we're going to have to do. Now, it's not pretty, but this will ultimately get it working. And so first what we'll do is we'll import in node fetch like so, and then we can use it. Now, you might be tempted to just pass it in directly. I tried it. This does not work. Essentially, we're going to get access to the request, which is of type web standard request. And then we need to do some work to actually use node fetch. So one of the things about node fetch is the first argument is always a URL. So we can pass in request.url. And then from there, we need to specify our headers because that's going to have the auth header and the content type. And so here I'm going to set headers equal to request.headers.entries, but this is an iterator. It's not an object of keys and values, so we need to turn it into that. So what I can use is object.fromEntries, pass this in, and then I do believe we need to spread it into an array for this to work properly. So this is going to give us all the headers from the request that got created by libsql client. And then lastly, we need to pass in the body of the request. And so this is the part that is somewhat cumbersome because essentially this request object has a readable stream that is the body. We need to convert that into a string so that way we can pass it into node fetch. honestly, maybe this is way too many steps. If you've been able to figure out Node.js Vercel deployment without doing this, I'd love to hear about it. Let me know down in the comments, but this is what we're going to have to do. So essentially we have to create a text decoder and then make sure that this is an async function so we can use await. We're then pulling in the body there from that request, reading it all, putting it into a string, and then we can actually pass it into our node fetch here. Okay, it's not pretty, but basically this is what I was able to do to get it working in the Node.js runtime. Another thing you can do is just install a different request library instead of node fetch, and then potentially pass the request in there. But this is one way to do it. So now, just to make sure that this runs locally, I'm going to run npm run vercel dev and make sure that that fetch function works, make sure that we can actually hit our endpoints. So if I head to /tasks, database is empty, but it still comes back. So at this point, we can attempt to redeploy it. Okay, it's deployed. Let's try it out. So if we head back over to the deployed instance and refresh, we can still get to the reference page. Let's try listing out our tasks. It didn't work. I forgot to promote the deployment. So I'm hitting the endpoint that is production. I need to make sure I do vercel --prod so that it promotes this instance to the production instance. Now let's give it a try. If I try to get our tasks, I forgot one thing. We need to specify the method. Oof. Okay, so over here, by default, it's a GET request. We need that method to be a POST request. So this is how the libsql client works. Essentially, it's making a POST request to that server that in turn is working with a SQLite database. Okay, so last thing we need, and then we should be good to go. Vercel prod. Okay, moment of truth. Third time's the charm. Sweet, we can get the data. So now we're deployed to Vercel in the Node.js runtime. And last but certainly not least, I'll show you how to deploy to Cloudflare. Now, Cloudflare is what Hono was actually built to deploy to. So it's fairly easy to get it going, but the main caveat here is I have done some things in this starter template that are not compatible directly with Cloudflare. So in Cloudflare, whenever you're working with environment variables or secrets, those are only accessible inside of the request, inside of the fetch event handler. So you can see in their example for like a simple worker, it gets access to env here. This is the only way you can get access to environment variables. And in the code that I wrote in our starter template, I have environment variables accessible from process.env, right? And so this is not going to work inside of Cloudflare. So what I'm going to show you is how we can set this up so that we have a runtime env. So that way, like our local build tools that need to use the env can work in the same way, but all of our request handlers are going to need to pull in those environment variables from the incoming request. So first up, I'm going to clone the repo down, and I'll put this into a Cloudflare example folder. We'll install dependencies, and then one thing we're going to need is Wrangler. So Wrangler is Cloudflare's CLI tool that allows us to test locally and then also easily deploy. So we're going to install this as a dev dependency. Awesome. So we have that as a dev dependency. Now we're going to need a wrangler.toml file. If you head over to hono.js/starter, they have all of the templates that are used whenever you're using the Hono CLI, and we can look at the Cloudflare workers example to get all of our setup code here. So if you look at this wrangler.toml, this is exactly what we're going to need. So I'm just going to copy this stuff here. And then here, I'll create that file wrangler.toml, and throw that in. But I do need to give it a name. You can see in their example, they're using like a template, but I'm just going to call this the Hono starter Cloudflare. Awesome. So this is our file, and you can see that it has a main entry point of source/index.ts, but that's not quite what we want. So if you look in their example, source/index.ts exports a Hono app. And if you remember, we have an entry point for our Hono app. So if we take a look, our index.ts is the one that uses node server. We don't want that. We want to pass it in this, because this is just exporting a simple Hono app. So right here, we'll need to make sure that this says app.ts. From there, if we take a look at their package.json, they have two scripts, a dev script and a deploy script. So we're actually going to replace our dev script with this one, and then we'll also add this deploy script. So over in our package.json, we'll replace our dev script like so, and that looks good. And then one last thing is they do have the Cloudflare worker types, so we'll be sure to install this as a dev dependency too. So if we copy that, we can do an npmi-D Cloudflare worker types. Awesome. So we're set up, but now come the code changes, because like I said, we cannot access this env at runtime. It has to be within a request, so we're going to have to refactor our codes. So the first thing I'll do is I'm actually going to rename our env type. So this is the type that we've defined here with our Zod schema. I'm just going to rename this to environment. And the reason I'm doing this is it'll work more easily with the built-in Hono types. Okay, so that's called environment. Next up, I am not going to export this env from here. So anywhere that was importing env, that code is going to break, and I'm going to have to fix it to import from somewhere else. Then I'm going to export a function called parseEnv, and this is just going to accept anything. So it's going to accept an object and then use our Zod parser to validate that incoming object. And then instead of passing in process.env, I'll pass in that data. Safe parse gives us back data, so we're just going to rename that to env. And then here I'm going to return that env. So essentially, whenever we want to validate the env and get access to those variables, we're going to pass in the thing that should have those variables. It'll validate it, and then we'll get back the object that has those validated values. Now, in this case, we don't want to exit the process. We actually want to throw an error. So I'm just going to create a simple little error message here that kind of combines everything into one. So we're going to grab this error.flatten.filled errors. We'll turn this into a template string. Like technically you could just pass in the JSON data, but I want this to be nice and readable if I do get this as an error message. So I'm going to throw this in here. So filled errors is an object where it has the specific environment variable and then the associated errors if there were some. So what I will do is actually use object.entries. And so this is going to give me an array of arrays. So each array is going to have the key as the first value, and then that array of errors as the second value. And so for each of these, I want to turn it into a single string. So I'm going to map over this. We're going to destructure it, grab the key, and then the errors, and then I'll return another template string that says the environment variable name, which is the key, and then specifies those errors. And so right here, I'm going to say errors.join. We'll just join them with a comma like that. And so essentially, this is going to give me an array where you have environment variable name and then a list of errors for all of those. And now I want to take that entire thing and then join that all together into a single string. So I'm actually going to join this with just like a pipe like this, a single pipe. Okay, it's a lot. You don't have to do this. Like I said, you can just JSON stringify it. But if you want this code, check the link in the description. I'll have this deployment code and you can just go copy this. Okay, but now that we have that error message, I'm just going to throw a new error and pass that error message in. So essentially, anytime we try to parse the env, it's just going to throw an error. And I can actually use this inside of a middleware. So I can have a middleware that gets access to the current env, tries to parse it, and then if something is missing, it'll throw an error. Our default error handler will catch it, and then we'll actually see that in our logs that says, hey, you're missing some environment variables. So let's do just that. I'm going to head over to where we create the application here inside of create app. And basically what I want to do is have a middleware that's the first thing that runs before any other handler, before any other middleware, and it's going to validate that incoming env. So right here, I'll say app.use. We get access to the context and next, and then I can attempt to validate it. So I'm going to call parseEnv and make sure that I import it from env. That's the function that we just wrote. And I'm going to pass in c.env. C.env are all of the built-in secrets and variables that get passed to your handler. And Hono makes that available there on the context. So we're going to pass that in. Right now, you can see that it's the unknown type. I'll show you how we could set the type on it in a second. And then after this, we just say next, like so. And so what's going to happen is a request comes into our Hono app, and then we're going to validate that env. If any secrets are missing, it's going to throw an error and then immediately just respond with that error. Otherwise, it'll go on, and then every other middleware or function that needs to use that env will get access to it. Now, let's actually set up this type. So you can see right here that the type is unknown, but this type can be set inside of our app bindings type. So if we head to app bindings, now the type that we pass in here to when we're creating a Hono instance or an OpenAPI Hono instance can also have a bindings property. And so if you look in the Hono docs, you can see here under app and then generics, we can pass in our bindings, and then this has all of the available environment variables. And so we can do just that. I'll pass in bindings, but we can use that type we created. So I'll pull in our environment type from env, and now we're good to go. And so that type has all of the environment variables that we should have access to, and now that's just flowing through to the bindings. And so if we head back over to where we defined this middleware, now when I hover over env, you can see that it has that specific type. And so anywhere else in my application where I need to use those environment variables, I'll do c.env, and I'll get good type completion. Now, to make sure that whenever we're running our code not inside of Cloudflare, and we want to load those environment variables from process.env, we need to do something extra here. So basically what I want to do is I want to reassign c.env to be the parsed env. And the thing I pass in is going to be a combination of c.env and process.env if it exists. So to combine these two things together, I'm going to use object.assign. So you could use like the spread operator, but essentially object.assign is going to take the properties of both and put them into a single object. So from here, I'm just going to disable this linter error. And now whenever our app is running, whether the environment variables are coming from Cloudflare or they're coming from process.env, every other request handler that accesses c.env is sure to have those values. Now, env could actually be undefined when we're not running in a Cloudflare worker, so I'm just going to pass in the empty object here. Now, if we look at all the middlewares in our stack, the Pinot logger is the first place where we actually access that context. So this is what we're going to need to update. You can see right now it was trying to import from our env file, but that file does not export anything anymore. So we can't do that. Essentially, we need to get access to the context so we can access c.env inside of this logger here. So to do that, I'm going to return my own middleware that has the context and the next function, and then it's going to return the creation of this middleware here. So we do like this. Now, because we're returning this function, we also need to invoke it and pass the context and next into it. So we can do this. And this is the JavaScript code that we need, but if we want it to be type safe, we're going to have to do some extra stuff. So first of all, if we want to define the type of this function, one that's returning locker, it is a middleware handler. So right here, we can say satisfies and then pass in middleware handler. This is a type that comes from Hono. Now I need to make sure that I wrap this in parentheses, so that way it's happy. But now we should get some typings on C. So if we look at C, it appears as the context and the next is the next function. But if I want to be able to do c.env in a type safe way, then I also need to pass in my app bindings, right? Because right now, if I look at env, it's the any type, but we do have our app bindings type. And you can see the middleware handler type is a generic type that takes in an env, and that's essentially our app bindings type. So right here, I can pass in app bindings and import that in from my types. And this is the thing that we're also passing in whenever we create our Hono app. And this is the thing that also defines what our bindings should be. And so now, with those typings, when I hover over c.env, it has the correct type inference, and I'm getting access to those variables that I need. Now, lastly, the context type here doesn't align with the context type of the Pinot logger, so we can actually just define that type directly. So here we can just say context. So context is a type that comes from Hono. And then here we can pass in the env that's provided by Pinot logger. So they actually export a capital E env from Hono Pinot. And this is the type that actually includes that Pinot logger binding, right? So there's that type there. And then this isn't happy because it can't convert this type to that type. So we are going to use an unknown right here. So we'll say as unknown as that. And then TypeScript is happy. So the next spot we need to take care of is whenever we're creating the database connection, because if we take a look at that code, that needs access to process.env so that it can pass in the database URL and database auth token. But essentially what we'll need to do is recreate this client and database connection on every incoming request. So the request comes in, we get access to that c.env, and then we can use those variables there. So of course, we don't have access to env anymore because it's not exported. And so essentially what I'm going to do is create a function that returns client and returns db and allows us to pass in our environment variables. So I'm going to export a function called createDB. And this takes in the env, which is going to be of type environment. So we'll pull that in from env. And then inside of here, we'll create our client, we'll create our DB, and then I'm just going to return both of those. So return DB and client like that. And so now anywhere that needs access to DB is going to have to call this function and pass the env in. And if we run our type check command, we should see all of our type errors. Now we're going to have a few more beyond just importing DB, but let's see what happens. So yeah, we can see that in all of our request handlers that access DB, it can't do that anymore because that file does not export DB. And the main place that this is happening is our request handler. So if we head over to routes and then tasks and then handlers, this is where we access the DB, right? But it's not exported anymore. The only thing that we export is createDB. And so what we'll need to do inside of each of these handlers is create that DB using the environment variables. So here I can say DB is createDB, and then pass in the env. Inside of here, context has the correct type, right? So if I pass in c.env, you'll notice that TypeScript doesn't complain because we told it that it's going to be of this specific type. And essentially that app route handler helper that we defined in the other video passes in the app bindings, which has access to the bindings and the environment type. So this is completely happy. And so essentially when this request comes in, we can create that DB instance and then use it to make the query. And right now, this isn't the default export. So I don't want it to be the default export. I want this to just be an export so I don't confuse the default export with it. So this module should just export a function called createDB. And then in this case, we're going to have to destructure it, right? Because we return the client and the DB. So we're just going to pull off the DB there. and the codes are happy. So essentially what I'm going to do is do this inside of each of my handlers that needs access to the DB. And when you're deploying things to Cloudflare workers, this is how you'll do things, because each one of these requests is kind of like a serverless function, right? It basically just spins up, and that's when you'll need to create that database connection. So we're not really duplicating work here, especially because this is going to be running inside of Cloudflare. So I'll also add this here. So that looks good. And we're getting a type error here for our query, but I'm going to ignore that from now. And if I fix it, I'll come back to it later in the video. Now, at this point, if we run a type check again, the only spots that should complain are the ones that we're trying to access the env directly. We take a look, it's in our drizzle config. It's inside of our main entry point, which we don't need anymore because we're going to be using Cloudflare workers. And then it's inside of our tests. So if we take a look, for instance, at the drizzle config, this doesn't run in the context of Cloudflare workers. This is only running on my machine when I run like drizzle-kit push or drizzle-kit studio. So I do somehow need access to the env here. So what I'm going to do is create another file called runtime env. And any file that basically needs the environment variables at runtime, not inside of Cloudflare, can use that specific import. So I'm going to create env-runtime. And all I'm going to export from here is a call to parse env and pass in the process.env. So I'm going to say export default parse env, which is the function we defined there in our env module. And then we're going to pass in process.env right here. And then I'll ignore my linter error. And so any place that does actually need access to this at runtime can import this file. So over here, we're going to import this from env-runtime. And then same thing inside of our tests. So if we head over to routes and then test, we'll import our env here from env-runtime. Okay, if we run a type check again, the only spot that is now complaining is our main entry point, which we actually don't need anymore. So if we look at this index.ts, this is the one that was pulling the app in and then calling it with node server. We don't need to do this anymore because we're running our app using Wrangler and then using Cloudflare. So I'm actually just going to delete this file. Okay. From here, I'm going to try to run the tests. This is one of the nice things about having a comprehensive test suite is I can make all of these refactors. And if the tests pass, I know I did everything right. And they do pass. So at this point, we can try running it locally with Wrangler because at least our tests are running, and the tests are running in the context of node.js, right? It's running locally with vtest, which uses using node, and then also compiling our TypeScript. But when we run with Wrangler, it's going to run it in an environment that's similar to how it will be running when it's actually deployed to Cloudflare. So let's give it a try. If we do npm run dev, that's going to run Wrangler. Now we do get one error where we're importing our package.json. So if we take a look in where we're configuring OpenAPI, we want to pull in that version number from the package.json. So in this case, I use this ESM way of importing JSON modules, but we can actually just not include that and it should still be able to bring it in. So to make sure this is a truly fresh install, I'm just going to remove all of my node modules and then do a npm install. Now let's reload VS Code. I have a feeling that this npm install also fixed the drizzle error we were getting earlier. So if we take a look in here and then take a look at our handlers, yeah, this doesn't throwing a type error anymore. Okay, for some reason our node modules are out of date, but now we can give it a try. So if I do npm run dev, okay, so I was doing some digging and the CLI tool that clones that Hono starter template for Cloudflare workers actually has some code that goes in and updates the compat date to be today's date. So I'm going to try doing that. If I set this to today's date and then save that and then try running Wrangler, that at least does an error for us. It says the latest compatibility date is this one. So I'm going to grab that one, update here. All right, hope for the best. Let's try running it now. All right, it looks like the app has spun up and now I can request 8787. Sweet, this is what we want to see. So now our app is running with Wrangler and you can actually see that it tries to parse the env and I don't have a log level, I don't have a database URL. And so the way that you create secrets for Cloudflare workers is by creating a .dev.vars file. So in order to actually read those variables in, we need to make sure that we have a dev.vars file. So what I'll do is just copy my env into a file called .dev.vars. And then I'll need to make sure that I add this to my gitignore as well. So down here, we'll add .dev.vars because this will potentially have secrets in it. We want to make sure that we don't push those up. And with that, we'll start it back up. We can see that it loaded in my environment variables. So this is good. Now let's try making a request to our app again. The root loads. Sweet. Let's try out some of our endpoints. So if we head to reference and then we try to load all of our tasks, this should fail because there is no database. We haven't even done a migration. Let's see what happens. We get a different error that I've already debugged for you. So it says URL scheme not supported. The client that uses web standard APIs supports only libsql, HTTPS, or HTTP and GOT file. So when we're working with web SQL locally and Cloudflare workers, we actually can't use this file URL here. Now we could actually just put our turso URL directly, but then we're actually like talking to the production database when working locally. So one thing we can use is the turso dev command, which will give us just a local host URL that we can pass in here. So if you head to the turso docs, they have a section here on local development, and we can use the turso CLI to spin up a database. And you can actually pass in a database name, and then it gives you just a local host URL that you can use to talk to that database. And so if we want to combine turso with Cloudflare workers, essentially we'll need to do this when we're running locally. So first, let's install turso as a dev dependency. And then I'm going to add another script here called dev.db. And this will essentially run turso dev, but I always wanted to look at that same local database. So I'm going to copy their run command here and then point it to dev.db. And so now locally, we can run this command in a separate terminal that starts up the turso server, and then we can have our app connect to it over localhost. So that looks good. One thing I'll do before that is to actually create the database and push the schema to it, so that way this file exists whenever turso dev spins up. So here we'll just do pnpm drizzle-kit push. I should be able to read my env just fine. Remember, we updated it to use the runtime env, and then it actually creates that database. So if we look in our local folder, we now have that dev.db file. But now if I run npm run dev.db, that'll start up the turso CLI and then use that specific database. Now, when you spin up the turso dev instance, it actually creates some files next to your database. We're going to need to make sure that we ignore those as well. So in our git ignore, I'm just going to do dev.db.star. So that way we don't commit that extra stuff to Git. And so now I can use this URL to connect to it. So if I head back over to my dev.vars, I'm going to point it here and then restart my app. And now it should use the turso HTTP localhost API to connect to the database, and we should be able to run our endpoints. So in another terminal, I'll run npm run dev. This starts up Cloudflare worker. We can now visit it. And if we head back over to our docs and try to list all of the tasks, looks good. We get back an empty array. And so now we can even try creating like a local task. Let's do that. The name is learn Cloudflare workers. Set this to false because we got lots of learning to do. That puts it in the database. And then I should be able to list them all. And we can. Awesome. So locally, I've got Wrangler running that runs my app as a Cloudflare worker on my local machine. I've also got the turso dev CLI, so that way I have a local DB. But now we can try deploying. And so earlier when we copied this into our project, it added a deploy command. And so we can just run npm run deploy from the CLI. Now for this, you'll need to make sure that you have a Cloudflare account and you've enabled workers and everything else. But because I have, we should be able to run it. So if I do npm run deploy, sweet. And if I try to visit it, it needs some environment variables, but this is good. This is good. It's in the cloud. So let's head to our Cloudflare dashboard and then set up all of our secrets. So here in my dashboard, I can go into my app. And then if I click on settings, there is a section for variables and secrets. And so I'll go in here, add all of my variables. I'll add my node.env, log level, my database URL, the one that points to turso, and my database auth secret. So I'm going to go through and do all of that now. And in this case, I don't want to redeploy for every single variable. So I'm just going to say save and then add all of them, and then I'll redeploy. Now, since we added those variables and deployed from the Cloudflare dashboard, if you attempt to deploy from your CLI, you will see a warning that says, edits that have been made via the dashboard will be overridden by your local code and config. So you don't want that. So we're going to say no, not continue, but we'll just make sure that in our wrangler.toml, we can add the setting keep vars. And this will make sure if we added anything in the Cloudflare dashboard, it will not override it when we run our local deployment. And then now if I run deploy, it's going to give me this warning still, but it's not going to override our environment variables. And if we refresh, those variables exist. So now if we go to /reference, it loads. But if we make the request here, it should load the data from our turso DB. And it does. So let's actually patch that task. So we're going to patch the task with ID 1. And we're going to set done to true. Here we go. Sweet. Now done is set to true. That's it for this video. Thank you so much for watching. There's a lot more stuff I want to explore with Hono, but hopefully this got you started on deploying your Node.js apps. If there's anything I didn't cover or anything you're having issues with, let me know down in the comments, and I'll see you in the next one.